This is Rylan Murphy presenting a technique detailing the creation of a 3D printed model for the preoperative planning of hip arthroscopy for femoral acetabular impingement. First, DICOM files are uploaded into Horos. Next, we select the correct imaging. We are looking for a high slice count axial CT scan with soft tissue view. Once the CT scan has been selected, under 3D Viewer, we will select 3D Surface Rendering. To optimize the quality of the print, we will set the resolution to high and the decimate resolution to 0.1. Next, we will change the smooth iterations value to 1. Selecting a value greater than 1 will result in the smoothing of the surface of the print and the loss of fine anatomic detail. Next, we select the reference Hounsfield unit. From experience, a good starting point is 220. Then the value can be adjusted from there. If more bone needs to be modeled, the value can be decreased, though this often results in a loss of fine details and definition of the joints. If less bone needs to be modeled, the value can be increased. However, this can create incomplete rendering of the bony structure. After a short inspection to ensure accurate rendering, we are now ready to export this model as an STL file. Now we can import the Horos file into MeshMixer using the top left-hand corner button. The next step is to remove the tray as seen in the three-dimensional model. This can be accomplished using the lasso tool that can be found underneath the select option icon. Once selected and highlighted, press the discard button. We will now isolate the left hip, which we will use to example the rest of the technique. This can be done using the plane cut tool underneath the edit option icon. We will again use the plane cut option to remove the sacrum. This removal of excess material will reduce both filament usage and print time. After all excess material has been removed, the next step is to create a flat surface for the model to rest upon while printing. This can be accomplished using the transform tool underneath the edit icon. The gridded marks can be used to ensure that there is even tripoding between the ischiopubic ramus and the femur. Next, we will use the plane cut tool on the bottom to ensure a greater surface area. This will allow for greater adherence to the build plate and stability of the print. We will also use the plane cut tool to remove the ilium. The last step in MeshMixer is using the inspector tool found underneath the analysis icon. The inspector tool will remove any floating islands of 3D model and will patch any holes left behind from either the lasso or the plane cut function. Now the model will be exported as an STL file from MeshMixer using the export icon on the left toolbar. If you are using a MakerBot printer, the next step is to use the MakerBot print software. However, this STL object file can be imported into virtually any other brand of 3D printer software. After adding the MeshMixer file using the top left-hand corner Add Models button, we will now optimize our print settings. Underneath the Min Fill preset, we will change several settings underneath the Quick Settings icon. Changing to padded base and brims will increase the adherence to the build plate and overall increase the stability of the print. Due to the complex organic nature of the model created by the CT of the bone, additional infill leads to unnecessary structures that do not add to the overall strength of the model. By reducing the infill density to 0%, we are both reducing filament usage and print time. This same principle applies to the number of shells. The final and most important setting to change is underneath the supports and bridging. We want to change the support type to breakaway supports. Supports give structure when printing overhangs and ensure that the model does not collapse while it is printing. The final step is to export to USB using the bottom right-hand corner export button. Once exported, the USB can be plugged into your MakerBot printer, and then you can select to begin printing the file. An average hip can be expected to print between 12 and 18 hours and can cost between $5 and $7 of filament.